Are we going to get a artificial superintelligence explosion? We're talking about Leopold Aschenbrenner's new paper, Situational Awareness, and the first of his four claims that we're going to have an ASI or artificial superintelligence explosion. That's actually two different things. One is that we'll attain artificial superintelligence, which he defines as having AI systems that are smarter than every human or almost every human. And the second is that we'll have an intelligence explosion, or what AI researchers call a hard takeoff. So let's start with the first one, artificial superintelligence. That I think he makes a very good case for, and I think we're on very strong ground there. This graphic is key to his argument. He talks about the three forces of scaling and how we're able to essentially make sufficient progress in all three of those areas to unlock the scaling needed to get to artificial superintelligence. So the three factors are the physical compute, the algorithmic efficiencies, and then what he calls unhobbling or progress in the overall process of solving problems. I think unhobbling is a key component to his paper that's going to be very useful. So he gives some examples where we introduced chatbots, which made models far more usable, and then where we introduced agentic behavior that allows models to form long-term strategies and act on them. So the idea behind unhobbling is that we can get immediate gains by providing AI with these missing components. So AI models by themselves are missing much of the cognitive architecture that human beings have. They don't have long and short-term memory. They aren't very good with strategy. They don't have access to tools. So we have been, in the last year, especially improving on those things. Chain of thought prompting, agents, those are tools that help the model and pursue strategies on a longer term. Short-term memory models actually are stateless. They don't even remember what they just said. So you actually have to feed the conversation back into them so that they can maintain short-term memory. We routinely do that now in chat. That's one of the reasons that chat is so much more useful. Long-term memory is recording your interactions with the model, so it has some history of you and can then form more useful interactions based on that. And then tools would be things like having access to web search, having a coding environment. So those are examples of unhobbling that we've done now. There are plenty more that can be done. And what they do is they allow you to use the intelligence of the model. It has intelligence, but that doesn't mean it can actually effectively use it. Unhobbling is a big deal, and I think that's a great contribution on the part of Aschenbrenner to give a name like that. So now on to artificial superintelligence. There is no reason why AI would not exceed human intellect. We're actually quite close to this. He's actually fairly modest with this. He assesses that the best models are performing at a smart high schooler level, but I don't think that's true. And I'm basing that on Dr. Alan Thompson's work. He is an IQ researcher who tracks AI progress. And you can find his work at lifearchitect.ai. This chart that he's showing talks about the GPQA, which is the Google Proof Question Archive. And that is a test designed to be extremely hard. It's given to PhD level researchers. They have 30 minutes to answer a question, and they have access to any search tools they want on the web. And what we find is that a general PhD, given the bank of questions in different areas, can answer about 34%. A domain expert, so for example, somebody who's a PhD in chemistry, given the chemistry, can do maybe 65%. But you see that our top models are already scoring above the general PhD level. So I would argue that we're already quite close to our top tier models being able to exceed human intellect for almost every human expert. So that's a pretty safe bet. I will give him that one. The next part, the intelligence explosion, is going to deserve a little bit more discussion. Stay